Hi, and welcome back to Management Information Systems. We're looking at Chapter 10 in your MIS6 book, and we're going to talk about building successful information systems. I'll be going through this chapter in these PowerPoint slides, and I am going to go through the important parts. There are quite a few slides, and I'm going to try to hit the things that I feel you will get the most from and a need to know, and kind of skim over the details that I feel are not as important. So we're going to talk about the systems development life cycle, and this is something that we deal with on a regular basis. And if we somehow forget to include that in any kind of thing that we do in management information systems, we get reminded by our bosses, believe me. And there's a lot of phases that are a part of the system development life cycle, and it does overlap into the project management area. There's planning, the planning phase, the requirements gathering phase, which is really, really important, the design phase, the implementation, maintenance phase, and then the architecture of these phases can be developed in different kinds of ways. So there's the rapid application development, there's the extreme programming, and there's the agile methodology. We use what's called the waterfall method at Madison College. So the system development life cycle is a series of phases that go in sequence that basically talk about that life cycle and how you go through it. Each phase's output becomes the input for the next phase. So as you leave one phase, you go into another phase. Here's a diagram of what you would be doing in each of the phases, and we'll talk a little bit about each of the phases and the kinds of things you would be doing with in each one of these phases. So a system designer may, for some reason, define that there's a problem in the organization, and it could be internally or externally. And what happens is an analysis comes in and assesses the current needs and the future needs of an organization and the strategic goals. And then they talk about whether it's something that they want to pursue as a project. An analyst has to get feedback from users on a problem. So this, for example, would be a good description of including your stakeholders in identifying what your problem is and what requirements are a part of resolving the problem. You should include people as part of your task force, or we call them stakeholders, from different departments. You want technical advisors from other areas of the technology services area, top management, and also analysts. And what they do is they provide feedback and get involved with the project from the beginning. Internal users would be people who use the system regularly, like employees. External users might be the customers or the contractors. There's a joint application design, which is a collective activity which involves users from top management and IT professionals. We have what is called a tab group, and that's what we use for this particular JAD. We call it tab instead of JAD, and it helps ensure that the architecture or the requirements that are collected are sufficient for the project. And what happens is there's an analysis of the proposed solution or feasibility, and they just determine how you should go about accomplishing that. There's economic feasibility, so you may want to resolve a problem, or you may want to get the newest and greatest software so that you can become more efficient in the organization that you're in, but you also have to determine whether it's economically possible for you to do that. You have to make for sure that there's some cost effectiveness analysis. When is the payback? When are you going to receive the return on investment? What is the cost benefit analysis? So those kinds of things are really important to do when you're working with SDLC. There's the technical feasibility. Do we have the people with the skills necessary to be able to accomplish what we want to accomplish in an SDLC project? We have to find out if that's there and whether we can accomplish it, or if we need to bring people in that can help us with that particular part of the project. There's the operational feasibility. How well will the solution work? And then there's the scheduling feasibility. So how long is it going to take? What happens if we don't deliver it on time? So all of these things need to be looked at as you're working through a project. And then there's the legal feasibility. What kind of repercussions will happen? Is there anything that we need to be concerned about? Are there any laws that may be in jeopardy because we're implementing a project? The requirements gathering phase is a phase where you sit down and you look at what the problem is, and you do an analysis of the process that you're going to use in order to fix the problem. So you may have requirements that are necessary, and those absolutely have to be a part of the requirements gathering. So you may have to have a real-time integration. So it has to be real-time. That would be a requirement. There's analysis and design approaches. There's a structured system analysis and design, which uses a sequential approach. And there's also an object-oriented, which combines the process and data analysis. We use kind of a combination of both. It depends upon the kind of project that we're trying to work on. Sometimes one of these approaches fits better than the other. And here's a data flow diagram of an inventory management system. So a lot of times you will see organizations put things into flow charts, which helps them define their process better. And this is a context diagram of a management system. So this is a look at, again, a flow process of inventory for, in this case, it's ABC company. So the design is the realistic solution with the highest payoff and the details of the proposed solution. And those are usually outlined in the requirements that are gathered, which are both business requirements and technical requirements. The design can consist of conceptual design and logical design. Logical would be hardware and software. Conceptual would be overview of the system. And physical would be specific platforms. There's also computer-aided systems engineering tools, which can be helpful to analyze the development process or the processes that are being used to develop. I don't know of a lot of organizations that do use computer-aided systems engineering. I think that it would be something that will become more used in the future, but a lot of places are growing so rapidly they have a hard time keeping up with their documentation on their existing environment. So you have to have all the documentation in order to use a case tool. There's prototyping, where you have a small version of a system and you do a proof of concept, and that's to determine the feasibility of using what you've developed. The steps for prototyping are initial requirements, the prototype, and then evaluating, and then revise the prototype, and then you try to sell the prototype as something that can be used. You can use case tools and interface tools to program and develop. And there are, of course, a lot of advantages to using case tools, but as I said, there's not a ton of people out there that use them yet. Prototyping helps to increase the system's chance of success. It improves documentation, and it enhances communication. The disadvantages is the excessive support, and it may not reflect the final system's actual operation. It has kind of a misleading nature because prototypes are never exactly like the final system. Implementation. So implementation is the part where you actually go and implement what you've designed. So you acquire the new equipment or the hardware, you train employees, you plan the system, and you do the coding and testing. And then with the conversion part of the implementation, you may run the systems side by side, which may be the old system and the new system, and that's called a parallel. Or you may do a phased in and phased out. So you may add the new module and slowly phase in and phase out parts of a system. There's a plunge, which is a direct cutover, and we use that occasionally. There's a pilot, which means that you get to test something out before you use it. And there are different kinds of techniques that you can use to do the project management portion of your job, or the SDLC, which would be using a PERT, which is a program evaluation review technique, or a CPM, which is a critical path method. So these things are basically more of a documentation of how you're going to go about implementing a solution. Here's a look at a PERT network. There's also if you take a look at and have used Microsoft project, it has what's called a Gantt chart. And what that is a critical path, and it allows someone that's doing the analysis to monitor the progress of a project. And it helps you detect if you're having delays in a project. If you have not taken a project management class, I really suggest you do it. It is awesome, and it will change the way you think about how you do things. So here's a look at a Gantt chart. And a Gantt chart is just showing you where you are in a particular project. So an RFP is a written document with specific detailed specifications. And what it does is it tells vendors what exactly it is that you're going to need. And an RFI is a little bit different in that it's a request for information. So it may be information gathering from vendors to narrow the list of potential vendors that you might use. There's insourcing, or developing a team internally, and there's self-sourcing. And that means that end users develop information systems with no formal assistance from information security or information system team. There's a lot of advantages and disadvantages. There's the possible misuse of computing resources. You may miss some crucial data, documentation, inadequate security, and you may not be up to the information system standards. So we're talking about the disadvantages of not using information systems people to become a part of your team. You can miss so many things if you don't have them be part of your team. Another thing